Hello and welcome to another video. In this problem, we're going to be working on maximum element after decreasing and rearranging. And in here, you're given an array of positive numbers, and you want to perform some operations, possibly none, on the array, such that it follows the following conditions. The value of the first element must be 1, and the absolute difference between any two adjacent elements must be less than or equal to 1. There are two types of operations you can make. You can decrease the value of any element to a smaller positive integer, or you can rearrange these. Return the maximum possible value after performing the operations. So in these examples, they have 2, 2, 1, 2, 1, and the maximum value is 2. And in the second example, they have 1, 100, 1000, the maximum value is 3, because you can just make it 1, 2, 3. And the third example, we have 1, 2, 3, or 5, and it already satisfies the conditions. So from these examples, you can notice that like the best possible outcome you can have if your array is length n, let's say, the best maximum you can have is n, because the first element has to be 1, and then the best possible thing, also, they can only be 1 apart. So the best possible thing, let's say you have 5 elements, it has to be 1, and then increase by 1, increase by 1, increase by 1, right? So the best possible answer you can have for length n, like if n is 5 here, it would be 5. If n is 100, it would be 1 up to 100, and so on. So that's the first thing you can recognize. So let's just say we have a bunch of numbers. I'm going to kind of walk through two ways of doing this, and I'm going to actually code it both ways because they're both, well, at least the first one is super short. The second one's a little bit trickier, and funnily enough, as a problem I did a few days ago, the optimal solution or maybe not optimal, but the better solution in Big O actually runs slower on LeetCode. So it's just like test dependent, but I'll go over both of them. So let's say we have a bunch of numbers like 10, 8, 15, 16, 1, 7, right? And how do we actually do this? So the easy way, or more intuitive way, is you first sort the array, because you're going to want to have this like increasing sequence of 1 to n if possible. So we're going to sort it, and we'll say, okay, so we have 1, then we have 7, then we have 8, then we have 10, then we have 15, then we have 16. So once we sort it, then like I said, ideally, if this is an array of length 6, you want to just have 1, 2, 3, 4, 5, 6. So basically what you have to do is you have to keep track of like a result, and then keep track of like, since really all you can do is you can bring numbers down. If your numbers are too small, you can't like increase them, right? So for example, if all our numbers were 1s and 2s and we wanted 1, 2, 3, 4, 5, 6, that wouldn't be possible. But let's see if it's possible in this case. So what we would do is we'd start with like a result of 0. And then basically we're just going to go through all our numbers and see, is per number greater than result? If yes, then result equals result plus 1. Because remember, result can only increase by 1 at every single stage. And if not, right, because this is already sorted, if not, then result stays the same. And so let's kind of walk through this, and let's do like 2 examples here. So this sorted, we're going to go to the first number, and we're going to say, is the current number greater than the result? Yes, it is. So then the result has to be 1. And notice one of the requirements is the first number in the result has to be 1. So here, the result will be 1. Now we go to the next number, because remember, our ideal situation is 1, 2, 3, 4, 5, 6. So we check, is this number greater than the result? If it is, then the result is 2 now, and we can just we can always like make, if it's bigger, we can always make it smaller that it fits our criteria, right? So this will be 1. If this is bigger, we can always make it smaller. So we can always make this a 2. That's one of the operations. So this is bigger, so we'll turn result to 2 now. Remember, the result only increases by 1 every time. Now, is this number bigger than the result? Yes, it is. So we can make result equal to 3, and our operation would just be change this to a 3, right? Just keep decreasing it until it's a 3. Is this bigger than our result? Yes, it is. So then our result will be 4. Is this bigger than the result? Yes, it is. So then our result would be 5. Break, make this smaller again. And is this smaller? Is this bigger? Yes, it is. Right. So because in any 2 operations, you can either rearrange, so we are allowed to sort, and we can decrease. We're basically sorting to rearrange, because we are allowed to rearrange. And we're just saying, like, if it's possible to make this 1, 2, 3, 4, 5, 6, let's go with that. So that's one way. Now let's have another set of numbers, and I'm just going to write them out in sorted order because we're just going to sort to begin with anyway. So let's say we have something like So we have 1, 2, 2, 3, 3, 4, 4, 5, 8, let's say. So ideally, once again, we want to have 1, 2, 3, 4, 5, 6, 7, and so on. So let's walk through this example and let's see what would happen. So let's change the color here. We're just going to write the number that gets transformed into above it, maybe. So our result will be 0 again. So we're going to say here, is this bigger than the result? Yes, it is. So we are going to update our result to 1, and this is already 1. Is this bigger than the result? Yes, it is. So we're going to update our result to 2. This is the number we want. Is this bigger than the result? No, it's not. And we can't really do anything about it, right? I mean, we can like put in a bigger number now, but then we're going to have this 2. So ideally, you want to have it in sorted increasing order where you have it like this. So if this is not bigger than the result stays at 2. And is this bigger? Yes, it is. So now our result goes to 3. Is this bigger? No, it's not. So our result stays at 3. Is this bigger? Yes, it is. So our result is at 4. Is this bigger? No, it's not. So our result stays at 4. Is this bigger? Yes, it is. So our result is 5. And is this bigger? Yes, it is. And our result is 6. And we would just change this value to a 6, right? So we still have that property where every value is 1 apart. So we still have that property, and the biggest value here is 6. That's kind of like the first way of doing it, where you just sort and you just literally check, is this number big enough where I can just increase my result by 1? If yes, let's do that. If not, let's keep the result the same. And the only way, basically, it's not going to be big enough is if you have two numbers that are the same. Okay, so that's one way of doing it. And this is going to be an n log n solution, right? Because we're doing a sort. So there's another way of doing it. It's going to be kind of similar. So let's walk through. Well, it's going to be kind of similar. We're not going to be sorting. We're kind of going to be doing that bucket thing that we were doing in the last few problems. We're just going to get buckets and the number of numbers for every bucket. So the idea is, let's say we have, so this is 1, 2, 3, 4, 5, 6, 7, 8, 9. So if we have 9 numbers, what's the biggest number we can have? We can have 9, right? So if we have 9 numbers, we can only have this in our final outcome. So 1, 2, 3, 4, 5, 6, 7, 8, 9. This is in our final outcome. So any number bigger than 9 is going to be basically the same as 9, because we can't really get to any number bigger than 9, even if we increase at every stage. So any number bigger than 9, what we're going to do is we're just going to say it's 9. So if we have 100, 1,000, and all those things, we're going to turn those all into 9s because they will end up getting reduced to a 9 or less, right? So basically anything bigger than 9 or 9 is the same because it can fit anywhere. It's always going to be bigger than the result. So they're equivalent. So what we're going to do is we're going to bucket every single index that we want and a count. So let's say we have a bunch of numbers. Let's just have 9 numbers again. So let's say we have some random numbers like 10, 15, 2, 3, 8, 100. How many is it? 6. 3 again. And let's say we have a bunch of 3s. So something like this. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So we have 9 numbers. Now, instead of sorting, we're going to use this bucket technique where we know, okay, the biggest number we can have is 9. So we're going to have a variable for max num. We'll call that max or something. Obviously, we're not going to use max, but so we're going to have something like this. And essentially what we're going to do is for every number, we're just going to say if it's bigger than 9, we're just going to add 1 to the count of 9s that we have. And then we're going to have a dictionary of counts. So let's call this counts. And let's go through this. So 10 is bigger than 9, so we will have 9 with a count of 1. And let's maybe try to have this a little bit in order. So let's put the 9 down here with a count of 1. 15 is also bigger than 9, so we will change it to a 9 with a count of 2. 2, so we have 2 with a count of 1. We have 4 3s, so 3 with a count of 4. We have an 8 with a count of 1. And then we have this 100 with a count of 1, and so this 100 turns into a 9. Okay, so we have 9 numbers total. And the idea now is instead of sorting, we're going to go through every single number that we could have had in here. And because we reduced everything to 1 through 9, we're just going to go through 1 through 9. And we're going to see how many of those do we have, right? And the idea is for anytime our result is big, anytime our number is bigger than our result, we're just going to say, okay, how many of these numbers do we have, and then how many can we use? And let's kind of walk through the logic with that. So once again, we're going to have a starting result of 0. Okay. So remember, ideally we want to have 1 through 9 in our output array because that's the biggest sequence you can have. So let's walk through this. So first, we're going to go to index 1, and we're going to say, is there a 1? No, there's not. Then we're going to go to index 2, and we're going to say, is there a 2? Yes, there is, with a count of 1. So because 2 has a count of 1, there's only 1 in here, right? So that means our result, we can only increase it once. Because our result is 0, because we only have one number here, we can only increase the result once. And the maximum number we can increase the result to is only 2. So let's say 2 had a count of 100 and our result is 0. Well, we can't increase our result past 2 because we can't increase 2. We can only decrease 2. So we basically have to take the minimum of the count, right? We have to take the minimum of the count and the difference. So let's say our result is 0 and our number is 2. The most we can ever get that number up to is 2. So it's going to be the difference of result minus count. And the other value we care is the actual count, right? So we can only increase it count amount of times. And the reason we want to do this in we don't want to like while loop through, we don't want to while loop through every single one of these. We want to just calculate it on the spot. And so if we can only increase the result up to 2, the most we can increase it is result minus count. But we can only increase it by 1 every time we need to have a count, right? So let's say we can increase the result by 2. The only way we could increase the result by 2 is if we actually have 2 2s. So this is going to be the minimum of these 2, and that's the operation for every single count. So let's calculate this. So we have, or it's going to be actually the opposite. It's not going to be result minus count. It's going to be count minus the result. So it's going to be, or well, not count. It's going to be like the value, right? The value, or this key. Okay, so key minus result. So let's kind of walk through why that is. Okay. So our key is 2, right? We are trying to get our result up to 2. So key minus result is 2. The most we can get our result to is 2, but we only have 1 2. So if our result is 0, we can change this 2 to a 1, right? And then our result would become 1. But we don't have 2 2s, so we can only get our result up 1. So this result now transforms to 1. And then we check again. We checked 1, we checked 2, now we check 3. So 3 has a count of 4. And I'm actually going to write this out in our output array just to demonstrate it easier. So in the beginning, we have a 2. So we got our result up to 1 because our operation was basically take our 2 and change it down to a 1, right? Because we need it 1 through 9. Okay. Now for the 3, so our key minus result, so we have 3 minus 1 is 2. So the most we can increase our result is by 2. And how many 3s do we have? We have 4 3s. So because we have 4 3s, we can only increase our result by 2. And then to increase it by 1, you need one number. So the minimum here is 2. So what you're going to have is if you're going to have 4 3s, you could do something like, there's a bunch of different ways you could do this. But one of the ways would be like 1, 2, 3. So you decrease 2 3s to 2 and 3, and then, or you decrease 1 3 to 3, sorry, and then the rest of the 3s you would just write out like this. So this is one way of doing it. I think, yeah, there's other ways, right? You could do like 1 2 2, 3 3, and so on, but essentially something like this. So that kind of represents why it's the minimum of these 2, right? Even though we have a lot of 3s, we can't get our result to be above a 3 because we can't increase our 3. So then we go to 4. We don't have any 4s. We go to 5. We don't have any 5s. No 6s, no 7s. Now we go to 8 with a count of 1. And our result is currently actually 3. So if our result is 3, 8 has a count of 1. Once again, we do this key minus result. So the most we can increase the result is by 5 numbers, right? We can go like 5, we can go 4, 5, 6, 7, 8. But we need 5. We need a count of 5 to do that. We only have 1. So if we only have 1, we can only increase our result by 1 because we only have one number, and we have to increase it by 1. We can't increase it by more than that. So our result here would now turn into 4, and basically we take our 8 and turn it into a 4. Okay. Now we go to 9. It has a count of 3. So 9 with a count of 3. Our result is currently 4. So what's the most we can increase our result by? It's going to be 9 minus 4, which is 5. But we only have a count of 3. So we can only increase our result by 3. So this result will turn into a 7. And one of the possible operations would be take the first 9, turn it into a 5, take the second 9, turn it into a 6, take the third 9, turn it into a 7. I think it's the only way to do that. But that's kind of like what these are. So essentially, if I write these numbers on the top, this would be, we took, here's our numbers, right? So we took our 2, we turned it into a 1. These all used to be 3, so 3, 3, 3, 3. And then we had the 8, and then we have 9, 9, 9. So the blue is what the numbers used to be, and then the green is what we turned them into, right? We're essentially figuring out, like, okay, every time the number is bigger than the result, let's just add one more number than the result. And by using this equation, we're able to, if we have a bunch of one number, we're able to figure out how much can we increase the result by in O of 1, instead of looping through the number a bunch of times. Because that would be inefficient, right? Let's say you have 9, or let's say you have like a number like 100 with a count of like 50. You don't want to like loop through it. You just want to quickly calculate, like, okay, what's the most I can increase it? All right. So that's going to be pretty much it. This one's a little bit more confusing. The sorting is a little bit more straightforward. So now let's code up both, because it is relatively short. So let's start with the sorting. So we can sort the array, and we're going to have our result start at 0. And we're basically going to say for number in array, if number is greater than the result, that means we can increase our result by 1, right? We can just chop down our number to be result plus 1. So if this is the case, our result plus 1, and we can return result. And we can submit that. And funnily enough, this one is actually quite efficient, even though it's worse time complexity. So we could talk about this one real quick. So this one is going to be O of n log n, because we are sorting, and O of 1 space, right? Because we don't have any kind of extra variables. So that's the first one. So now let's go through the second one, which is a more complicated one. So we're going to have a default dict. You could also use an array. So we're going to have nums equals default dict of int. And the max number we can have, remember, so for an array of length n, the max number we can have is length n, right? If we have 9 numbers, we can have 1 through 9. So max number is going to be length of the array. And then essentially we're kind of doing the same thing. So we are going through for number in R, let's nums, if the number is bigger than max num, let's reduce it to max num, right? So we'll reduce it to minimum of num and max num. So if it's smaller than max num, let's keep it the way it is. Otherwise, let's reduce it to max num. So if we had like 100 here, this would reduce it down to 9 if our array was length 9. Okay, now we have the same thing. So result equals 0. And essentially, we're going to loop through every single index in the array. So we'll say for I in range. So what are our numbers? So our numbers, if an array is length 9, it's going to be 1 through 9. So it's going to be 1 to max num plus 1, right? So max num here would be 9. So 1 to 10, but it doesn't include 10, so it'd be 1 to 9. Essentially, we're going to say result plus equals that equation that we had, the minimum of the count of I, and how much can it actually increase this result, right? Which is I minus result. So if our I is like 9 and our result is 5, the most we can increase the result is by 4. So we have to figure out, do we have enough? If we have enough, we can increase it by 4. If we have too many, we can still only increase it by 4. And if we don't have enough, then we can only increase it by the count. And return the result. And funnily enough, like I said, this one actually runs slower, but in theory, it should be better. So this just kind of depends on LeetCode cases. So this one is actually O of n because we are traversing, the array here, right? So we're traversing the array here, and then we are basically traversing the length of the array here, and this is an O of 1 operation. So theoretically, it's still O of n, and this one does take space, so this is O of n space, because for every single index, we are keeping a count. So both solutions, just wanted to show those. This one's pretty quick, so I decided to do both. So hopefully you like this one. I think this is like the second or third problem actually where like the optimal solution actually did worse on LeetCode cases, but that's whatever. But yeah, I think that's going to be all for this one. So hopefully you like this one. And if you did, please like the video and subscribe to the channel. And I'll see you in the next one. Thanks for watching.